Saturn is a fascinating world, but the most obvious thing about Saturn is the rings of Saturn. And these rings are something that look a little bit different times you look at it, but they always get these rings when you even use a small telescope. Galileo even saw the rings. He didn't see them as rings, so his telescope wasn't all that good, but he saw bumps on the side of Saturn. And today's even cheap little telescopes will show you the rings. Now, the rings do always look a little bit different because of different perspectives. Saturn is tilted as it goes around the sun, and Earth is very close to the sun compared with Saturn. And so viewing here from near the sun, where Earth is, remember, sun is 1 AU from Earth. So Earth's 1 AU from the sun. Saturn's almost 10 AU away from the sun. And so it's quite a bit farther away, and so this drawing is actually not that bad of a perspective. So as the Saturn orbits around the sun, sometimes from Earth we see the rings lined up with Earth's orbit, and the rings look edge-on. At other times, when the north pole of Saturn is pointed towards the sun, we look at it and we see the northern top side of the rings, and then other times we see the bottom down here. And so that'd be when the south pole is pointed towards the sun. So these are the orientations. You can also often see the shadow of the planet on the rings, and sometimes the shadow of the rings on the planet. So here's some oppositions of Saturn from 2001 to 2029. That's about a complete cycle of Saturn's orbit right there. And about 29.5 years is one orbit of Saturn. That's actually kind of telling, because some years ago I was giving a public star party and was pointing out constellations and planets, and I noticed that Saturn was very close to the front of Scorpius. And it kind of dawned on me right then and there that when I first started astronomy, started teaching as a lab assistant doing astronomy, that Saturn was very close to that same star. And so now it was back again. So that means I've been doing astronomy for 29 years. And so, but that's about how long it takes to go through a complete cycle of the of its orbit. And so the rings look variously differently as you look. So as we look at Saturn, about every almost 15 years, we have a ring crossing event in which the rings are edge-on. Now, when they're absolutely edge-on, you don't see rings. So 2009, that happened, but Saturn was too close to the sun to actually see anything. But the time prior to that, which was in the 1990s, I remember seeing Saturn, and for the first time, I had seen Saturn actually with no rings at all, because this ring crossing event was well placed in the evening skies, and so we saw Saturn with no rings. It was just kind of a weird-looking thing to see no rings there. The next ring crossing event is going to be 2025. Once again, viewed from Earth, the Saturn's going to be too close to the sun to really see that there's no rings there. The next ring crossing event in which you can easily see that there's no rings around Saturn is going to be in 2038. So just hang on, 2038, and you'll be able to see Saturn with no rings. And that's actually an interesting thing, because you're used to seeing Saturn with rings. Even when there's no rings there, again, 1990s here, 1995, summer of 95, there were no rings around Saturn, because it was edge-on to us. And so even the Hubble telescope had difficulty seeing rings for a few days there when they were directly edge-on. What does that mean? Well, the Hubble telescope can see some pretty small things, really far away. That means the rings have to be very small. it's possible the rings are no more than 100 meters thick. Well, that's about the size of a football field with end zones. Thickness, that would be the thickness of the rings here. And so that means that they are really, considering how big Saturn is, how big these ring systems are, that's amazingly thin. That means that if they're that thin, how come you do see them at all? How come you're not just seeing through them? That's because they have to be very, very high albedo particles. They're ice. They are ice particles, and they reflect an enormous amount of light because they're ice particles. The first astronomer to really figure out what the rings were in terms of rings was Christian Huygens. We had Galileo a few years earlier had seen rings around Saturn, but he didn't recognize them as rings. His telescope wasn't very good, and so to him it just looked like there were bumps on the side of Saturn. Huygens, though, with his better telescopes, was able to pick out that these really were rings. Now, that's important, and he did this just a few years after Galileo's problems. And so at the time, he was actually very afraid of getting in trouble or being declared a heretic that Saturn had rings around it. But in the few years after Galileo, other astronomers had looked at Jupiter and seen moons around Jupiter. And so Huygens was thinking, well, if he found a moon around Saturn, that's not going to be a terribly controversial discovery. In fact, he did find a moon around Saturn, the moon that we call Titan. And so he decided that maybe it would not get him into enormous trouble if he just said that Saturn had a moon. And so he published a paper saying that Saturn had a moon, but the first letter of each paragraph spelled out in Latin that Saturn also had a ring that totally circled the planet but nowhere touched it. And that way, if someone else discovered the ring and got famous, he could say, see, I found it first. Here it is hidden in this paper about the moon. Whereas, on the other hand, if someone found what that said in his paper and he got in trouble, he could say, oh, wow, what an amazing coincidence, it spells that out. The nature of the rings was always a mystery. James Clerk Maxwell, who was famous for doing optics, also studied the rings and showed mathematically they cannot be solid because the inner part of the ring would have to try to orbit faster than the outer part. This is how orbits work. The closer you are, the faster the orbit. And this inner part of the orbit would have to go faster than the outer part. So that means if the rings were solid, there'd be a shear force on them trying to rip them apart. And Maxwell showed that that shear force is stronger than any substance known on Earth. And so the rings cannot be solid. They have to be made up of individual particles that are going around at different speeds. A few years later, James Keeler actually detects a Doppler shift in the rings, indicating that the inner rings had a bigger Doppler shift than the outer rings, meaning that they were going faster. So once again, proof that the rings were not solid. When you look at the rings, even with a very small telescope, you notice there's a gap in the rings. That gap, they actually decided separates two rings. The outer ring is the A ring, the inner ring is the B ring. And so that gap there was called the Cassini Division, named after Cassini, who recorded that. If you look very, very carefully at that picture, in the outermost part of the A ring is a tiny little dark line in there. That's called the Encke division or the Encke gap, after another astronomer, Encke, who a German astronomer who observed that ring in there. So it's within the A ring. Now, if you got really good eyes, you can also notice that inside the B ring is a really, really faint ring inside there, and that is called the C ring. So there's multiple rings that are here. We have the B ring, We have the A ring, which has the inky gap in it right there. We have the C ring in here. Okay. Later, they discovered some other rings. They labeled them in order, the D ring, E ring, and then finally a thin little line right here on the outside of there called the F ring. So the A ring, B ring, C ring are A ring and B ring are easy to see with small telescopes. C ring is easy to see with large amateur telescopes. The D ring was not really visible until you got close to Saturn, and you see that that D ring, it has particles in it that go all the way down to the atmosphere. And then the E ring was discovered out near where the moons are. We'll talk more about the E ring later. But this is a very diffuse sort of ring. It's not at all visible until you get up close. And you just notice there's a faint haze out there near those inner moons. That ring right there is really hard to define as a ring. It's more like a swarm of particles out there, a swarm of ice particles. And then finally, the F ring, which was discovered right near the outer edge of the A ring. This is a picture of the rings as seen from the Voyager spacecraft up close. And one thing that was a mystery until they got up close was, how the ring's structured. And they find there's actually a whole bunch of little lines in here that are ringlets, that the rings themselves are actually divided up into smaller rings, okay, all orbiting around. The other thing you notice in this picture right here is these spokes right here that stick outwards from Saturn, and they go around, but they go around not at the speed the rings go around, they go around the speed that Saturn goes around. That suggests that they're really magnetic features, that they are particles associated with the rings caught in Saturn's magnetic field. And so as Saturn rotates, those spokes go around with it. So they're actually particles caught in the magnetic field of Saturn. This is a color enhanced view of the rings from a Voyager picture right here. Those are definitely not the colors of the rings. The rings tend to be kind of a creamish color, but if you look at the color slightly, there's just ever so slightly variance of that color. And so if you use the computer to really sort of enhance those tiny little subtle shades, and you get something that looks kind of like this. And so that gives you these ring colorations. Why do things have color? They have color because they're made of different stuff. And so that would suggest that these rings got very slightly different compositions. Not massively different compositions, but very slightly different compositions. The idea that there's different compositions is also enhanced by the Cassini spacecraft, which did thermal imaging of the rings, in which here we have color variations due to temperature. And what we find is that some of these ring particles are cooler than others. The blue is very cold, so that would suggest that the B ring is very cold, but the C ring and the A ring are just cool, and that D ring is actually quite warm by comparison.